Bismillahirrahmanirrahim. Greetings. In the previous lecture or lectures, let's say, we discussed about prime numbers and also composite number, how to decompose composite number into its corresponding prime factors. And I also shared with you a technique, we called it Alice vertical technique, that is kind of very simple and efficient to decompose a composite number. Now, in doing arithmetic with fractions, we do need a least common multiple and greatest common divisor. And both of them, they deal with prime factorization. You will see when I make an example. So for this reason, we are going to, in a sense, review the decomposition of a composite number one more time. Okay, now aside, let me say a few words about fractions and before I go to the body of the lecture. Now, fractions are positive rational numbers. Numbers in the form of A over B, where A and B are natural numbers. We call them fraction. Now, for this level, for the developmental mathematics level, we have three kinds of fractions. Proper fractions, improper fractions, and mixed fractions. Sometimes they are called mixed numbers. Now, proper fractions are those fractions that the numerator is strictly smaller than denominator. The improper fraction are those fractions that the numerator is greater than or equal to denominator. Now, if you take an improper fraction and take the integer part of it out and write the fraction or the improper fraction next to it, that becomes mixed fraction. Like for example, 5 over 2, we can write it as what? 2 plus 1/2. 2 is a whole number, 1/2 is the improper fraction. We call it what? We call it mixed fractions. Now, a fraction is in reduced form if the numerator and denominator of that fractions are relatively prime. That means the only factor that they have in common, the only factor that divides both of them is 1. No other factor will divide both of them, both. We call them relatively prime. Now, the greatest common divisor, if the fraction, doesn't matter if it is proper or improper. If it is not, if numerator and denominator are not relatively prime, then dividing numerator and denominator of that fraction by their greatest common divisor, then that will reduce the fraction into simplest form, in which the numerator and denominator, they will be relatively prime. You follow me so far? Okay, then let me zoom this one and stay out of your way and take the lecture on the board if I may. Thank you. Okay, I have already talked about proper, improper, and mixed number. Now, the method for finding the greatest common divisor, two methods we are going to cover. One of them is a prime factorization method that I'm going to discuss in this lecture, and the other one is about Euclidean algorithm. The Euclidean algorithm, I will demonstrate that, and then I will put one full lecture for the deductive proof of this Euclidean algorithm. And that is a little bit possibly above the developmental mathematics level, but I make it very kind of explicit and trivial, hopefully, so that even the developmental mathematics students, which are really first time being exposed to them, they can hopefully completely follow that. Okay, now let's go to the body of the lecture, if I may. I have a selected easy problem first, so that we can comprehend. Then I go back to a little bit bigger problem in a sense. I keep apologizing for the primitive equipment I have. Inshallah soon I will get a good job, some good university, and I use their facilities. Now, 12 over 18, as we already know, we are familiar with, they are not relatively prime. Both of them are divisible by 2, by what else? By 3, by what else? 6. Is that right? Now, look at this one. They both are divisible by 2, yes, by 3, yes, by 6, yes, but 6 is the larger of the 3. 6 is the larger of the 3, and that is what we call it what? We call it the greatest common divisor, which means divides both of them, but out of all others that they divide, also both of them, 6 is the largest one. Now, how do we find 6? We want to use this one to learn from this so that we can apply it for a larger number. Now, I have used that vertical line technique here, and I used the prime factorization, and the 12 end up to be 2 to the 2 times 3. Is that right? 4 times 3. And I did the very same thing for the 18, and I end up with 2 times 3 times 3. You see that? So in order to find the, let me have the red pen. In order to find the greatest common divisor, as the name indicates, is a common divisor, which means it should be divisor of what? Of 12 and 18, but to be larger one. So you try to see what factors they have in common. They both have 2 and 3. Is that right? Look at that. Then you look for the 2 first to see, first of all, when you decompose them, write them in exponential form, as I did. Then you look for the let's say the first 2 and 2, you look for a smaller power. So the power of these 2 is 2, the power of these 2 is 1. So you select this one, because it's divisor for both of them. For example, this one 4 does divide 12, but 4 does not divide 18. You see that? But if you select 2, which is the lesser of the power, this is 2, this is 1, then 2 divides 12 and 2 also divides 18. You see that? You do the same thing with next factor. This 3 and this 3. This 3 has power of 1, that we usually don't write it. This 3 has power of 2, so we write the one that is smaller. So the power of both of them will be 1 and 1. So don't let your ear to kind of fool you in a sense that you think it's the greatest common divisor. You should be selected the bigger power. Exactly the other way around. Okay, now let me go and determine the greatest kind of larger number. This was kind of easier to comprehend. Okay. Now the number that I have selected are those that we are already familiar. I have used them in the previous lectures for vertical line, decomposition of them. One of them, we want to know what is the greatest common divisor of 1125, 1125, and 150. We are familiar with both of them from the previous lecture. Now again, I repeat myself, 150 we start with the first prime number and divisible by that, we go to this, then next prime number is 3 divisible by that, and so on and so forth, and we end up with 150 equals to 2 times 3 times 5 squared. You see, I wrote it into the exponential form. Now let me go to 1125. That is exactly what I have from the previous lecture, as a matter of fact, and see the factorization of that. Now here, as you notice, 1125, we start with 2 was not divisible by 2, then we start with 3, and we end up with 375. I don't go to detail because I have gone very detailed in the previous lecture, and we end up to 1125 in the exponential form to be 3 to the 2 times 5 to the 3. Do you follow me? This is the prime factorization of this in exponential form. Now, going back to, let me see what I had. It's over on the board. I'm looking for it with my desk. Yeah. Okay, now let me go here. No, 1125, as we already gone, he ended up to be 3 squared, 5 cubed. Then the other one, 150, ended up to be 2 times 3 times 5 squared. So what you do to find the greatest common divisor of these two, first you look to see what factors they have in common. Don't look at the power, all right? Just ignore the powers. This has 3, this has 3, so 3 is here. 5, this one has 5, this one has 5. We write that one. After you wrote them without the power, then you look for the smaller power, as we mentioned previously. 3 to the 2 and 3 to the 1 is 3 to the 1. Is that right? And then 5 to the 2 and 5 to the 3 will be 5 to the 2. Do you follow me? So that will be the greatest common divisor of these two numbers, 1125 and 150. Do you follow me? Now, look at this set now. This 1, 3, 5, 5 squared, 3 times 5, and 3 times 5 squared, all are what? Are common divisors of these two numbers. Every single of them divides both of them. Do you see that? But out of all of them, this one is the largest one. That is what we call it greatest common divisor. Divides both of them and is larger than other divisors. Okay, now let me see. I have the one small application of that. One small application of, there is a lot of application that I will be talking also in the coming lectures. And that is about greatest common divisor is 150 over 1125. This is not, they are not relatively prime, numerator and denominator, as we already know. Now I wrote numerator in expanded form in factor, in prime factor, and I wrote denominator in expanded form in factor form. Do you see that? And now look at that one. They have 3 in common, I cross them, 5 in common, I cross them, another 5 in common. You see that? So they have 5 squared in common, and what? And 3. So the greatest common divisor of both of them is 3 times 5 squared. So if I divide numerator, which is this one, by the greatest common divisor, which is this, and divide the denominator by the greatest common divisor, which is 3 times 5 squared, and I urge you to do that, it's very elementary, then we end up with 2 over 15. And 2 and 15, and notice, they are relatively prime, which means they have no factors in common, and the fraction is reduced. You see this large looking fraction reduced to 2 over 15, and that makes arithmetic with fraction much easier when we go to later. Okay, now let me zoom this one back and okay, then I thank you for watching, and as I said, in the 2 or 3 more lectures are going to come. The next one will be the least common multiple, and after that I'm going to go to Euclidean algorithm to find the greatest common divisor of 2 or more natural number, and then I go through the deductive proof of that. Again, I repeat myself, as I mentioned in the beginning of this lecture, is a little bit above the developmental mathematics, but a good student of developmental mathematics, even though they are beginner, they can comprehend it. And I present it in that way, so that is very comprehensible. Okay then, as always, I thank you for watching. I wish you, all my audience, all my those that they watch my videos, a good health and prosperity, and please stay and remain safe. So long.